Chapter 6, Section 1 is about the properties of polygons. And first of all, we have to define polygon. A polygon, the mathematical definition, is a closed plane figure. Closed plane figure made up of 3 or more segments. Made up of 3 or more segments. The side of a polygon is going to be a segment, and the vertex of a polygon is going to be a point. Side is a segment, the vertex is a point. The diagonal of a polygon is a segment drawn from 2 non-consecutive sides. Segment drawn from 2 non-consecutive sides. So that means the sides are not right next to each other. And then we have some special names. 3-sided polygon is a triangle. 4-sided polygon is a quadrilateral. Prefix quad means 4. 5-sided polygon is a pentagon. 6-sided is a hexagon. 6-sided is a hexagon. 7-sided is a heptagon. 8-sided is an octagon. 9-sided is a decagon. 10-sided is a dodecagon. And anything more than that we just call an n-gon. So these first examples, we just say yes or no whether they are a polygon. Number 1 is no. In order for it to be a polygon, it has to be segments. Letter B is a yes. C is a no. And C is not a polygon because it's not connected right here. D is a yes. E is a no. And it's a no because of that curve. S is a yes. G is a no. You can't have those segments crossing. And H is a yes. So determining whether the shapes are polygons. At the top of the next page, we have the definition of regular polygon. And in a regular polygon, all the sides are congruent and all the angles are congruent. Concave, the technical mathematical definition, is that it contains an outside diagonal. Contains an outside diagonal. And see how when we connect these two vertices, that diagonal is outside. And a convex is all inside diagonals. And I kind of like to think about this, that the concave is kicked in. So there's kind of like a little cave there. Concave is when you have one side that's kind of kicked in. Example 2, we are asked to tell whether each polygon is irregular or irregular, and then concave or convex. Well, this one we have all 4 sides the same. The angles are not congruent. So this is irregular, and that is convex. Letter B, our side lengths are different. so it is irregular. And then here is that outside diagonal, so that is concave. Letter C, 4 equal angles, 4 equal sides. So letter C is regular and convex. Letter D, 5 equal angles, 5 equal sides. That is also regular convex. Letter E, different size sides. So this is irregular. And we have that outside diagonal, or that part that's kicked in. So that is also concave. Letter F, our angles are all equal. The sides are not equal. So this is irregular and convex. Letter G, all of the angles are equal, all of the sides are equal. So that is regular and convex. And letter H, we have different size, different angle measures there. Looks like the sides are all the same, but the angles are not. So this is irregular and concave. Looking at this next section, we're talking about polygons, and we're talking about the sum of the interior angle measures. Triangle has 3 sides, and there's 1 triangle formed. So your interior angles are 180. If we have a quadrilateral here, and we draw a diagonal, we have 2 triangles formed. So there are 4 sides. We have 2 triangles, and the sum of the interior angles is 360. I kind of go over to this side. And if I draw a pentagon, it has 5 sides. And if we draw the diagonals, we have 3 triangles formed. And the sum of the angles is 540. Hexagon over here has 6 sides. And if I draw the diagonals, I have 1, 2, 3, 4 triangles formed. And the sum of the interior angles is 720. And I'm guessing you notice a pattern that's forming here. 7 sides, 2 fewer triangles, and with these, every time we add another 180 degrees. So a heptagon has 900 degrees. An octagon has 8 sides. There will be 6 triangles formed, and that will be 1080 degrees. This chart is here to develop a formula. Whatever the number of sides is, you subtract 2, and that's how many triangles are formed. And each of those triangles, the angles add up to 180. So we multiply n minus 2 times 180, and that is the sum of the interior angle measures. N minus 2 times 180. And that's what we have at the top of the next page. N minus 2 times 180 is our sum of the interior angles. And we're going to use that formula in the next ones. It says find the sum of the interior angle measures of a convex heptagon. Heptagon has 7 sides. So we're going to do 7 minus 2 times 180. 7 minus 2 is 5 times 180. And if you multiply that, sum of the interior angles is 900. Letter B asks us to find the measure of each individual interior angle of a regular 16-gon. So we're going to use our n minus 2 times 180 formula. We will do 16 minus 2 times 180, which is 14 times 180, which is 2,520. But that is the sum of all these angles added together. So what we need to do is take that 2,520 and divide by 16. And you end up with, right, my number isn't working out, right? You end up with 157.5. Divide that by 16, and each interior angle is 157.5 degrees. Looking at this one, says find the measure of each interior angle of pentagon ABCDE. Well, starting out with a pentagon, we will do n minus 2 times 180. So 5 minus 2 is 3 times 180. And you end up with 540 degrees, or the sum of those interior angles. Well, these interior angles all have an expression. So if we do 18C plus 32C plus 32C plus 18C plus 35C, that equals 540. All of those added together equal 540. Well, adding 18 plus 32 plus 32 plus 18 plus 35 is 135C equals 540. And then if we take the 540 and divide it by 135, our C equals 4. And we need to go back in, and if we do 18 times 4, this angle right here is 72 degrees. 32 times 4, this angle right here is 128 degrees. 32 times 4 is 128 degrees. 18 times 4 is 72 degrees. And 35 times 4 is 140 degrees. Sorry, it's a little bit messy right there, but those are our angle measures. Letter D, find the sum of the interior angle measures of a convex 15-gon. We're going to use our n minus 2 times 180. So 15 minus 2 times 180 is 13 times 180, which is 2,340. And letter E, find the measure of each, keyword there, each interior angle of a regular decagon. We will use our n minus 2 times 180 formula, which ends up being 10 minus 2 times 180, which is 8 times 180, which is 1,440. That's the sum of all the angles together, and we wanted each one, so we're going to divide by 10, and it is 144. And one more page here, the polygon exterior angle sum theorem. The sum of the exterior angles in a polygon, so the sum of the exterior angles is 360 degrees. No formulas, no nothing. Sum of your exterior angles is always 360. So our first one says, find the measure of each exterior angle of a regular 20gon. Well, 360 divided by 20 is 18 degrees. Exterior angle is 18 degrees. Letter B, we have all these expressions, so we need to add these together. 33b plus 16b plus 10b plus 28b plus 15b plus 18b. All of those add up to 360 degrees. Then we do 33 plus 16 plus 10 plus 28 plus 15 plus 18, and you end up with 120b equals 360. And if we divide everything by 120, our b equals 3. And that's all we were asked to do, is to find the measure of b, the value of b. And the last one, last two, find the measure of each exterior angle of a regular dodecagon. Exterior angles add up to 360. A dodecagon is 12 sides, and 360 divided by 12 is 30 degrees. And to find the value of r, we're going to do 4r plus 7r plus 5r plus 8r equals 360. And 4 plus 7 plus 5 plus 8 is 24r equals 360. And 360 divided by 24 is 15.